So in this video, I'm just going to give a quick demonstration of something that I came across that really helped me to understand how large language models behave and how you can control them to a certain degree. So essentially, what's going on in the background is they are predicting the next word or predicting the next token, and to be more precise, and I'll just show what that is. So they're just an incredible next token predictor. And you can tweak the code to actually force it to prioritize certain tokens, and that gives you an idea of actually what's going on behind the scenes, really. So in this example, a simple example where we want it to return a tool. So the question is track the order. Written that wrong. So track the order. Okay, so the tool that's going to be returned is going to be number 2, track the order. If we just, and I've set the max tokens to 1 here as well, so a token is just a word or a number, etc. If I just do that now, okay, it's getting number 2. That's a good example. If I do this enough times, so yeah, you can see that eventually, that actually took me a little while, but eventually we've got based has come back. And the reason that is because what that would say, if I just increase this maximum token to 100, it's actually saying a sentence. So it would say, based on the information I have, it's tool number 2. But we don't want it to do that. We want it to force it to return 1, 2, or 3 on every occasion. So if I just extend that to 100, you can say the tool, you can see the tool is number 2, blah, 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 based on this, etc. So the problem there is that if you had this as max tokens 1, yeah, you get 2 some of the time, but what we want to do is actually force it to have 1, 2, or 3 every single time. And that really just shows the inner mechanism of how the things are working. So you can actually add more weight to certain tokens. And just going into what token is. So a token, if we look at this, we've got the number 1 is token 16. And here we are. So you've got a token for, say, the or and it's just predicting this next token. That's what the large language model is doing. And Logit Bias forces it to prioritize certain tokens. So I've got 18, 16, and 17 here, which is essentially, you've got 1, 2, and 3. So we're going to say, you're going to prioritize the tokens 1, 2, and 3 so that they're coming back every single time, and there's no chance that you can ever send back anything else. Now, I could run this 100 times and you would only get that token back. If I ran it 100 times without this in place, it would start saying things like the tool that you need to run, which means that the first token returned would not be 2, it would be the or something. So if we increase the max tokens to 100 here, can see that it's being forced to have those tokens. So you're just getting those tokens back, 1, 2, or 3. But in a scenario where we want it to always return 1, 2, or 3, and that's all we want it to return, because you might have a system that needs to use that number in order to function and do something differently. And if it returned the or based on this information, the start of the sentence, it would mess it up. So that's just a little guide on sort of how they're thinking, how you can actually force the large language model to behave a little differently in the response based on Logit Bias, and basically just gave me a good understanding of actually what it's doing in the background and how we can tweak that to get the desired output, really. Thank you very much.